So when I was doing a lot of analysis on tweets, I was doing keyword searches. And the problem with keyword searches is different keywords have different names. They might have different meanings. They might have different connotations. I am not a natural language processor. And so this what kind of drew me to actually looking into natural language processing. And here's a quick explanation of why we need natural language processing and what the difference is. And um, this is kind of Noam Chomsky-esque. It's kind of relating to compilers and high and low level languages and designing a language. And so this is so the difference between the high level language is the more high level something is, the more it's programmer friendly, the more it's readable to programmers. But it has less memory efficient because the more high level or the less low level meaning more related to the system, the more conversions it needs to become machine friendly. So you're looking at a high level language, a scripting language, maybe like Python versus a lower level language like C plus or not or like C and so kind of going to the principle of that when designing a language for programmatically you have to be precise or not ambiguous. There has to be a known way to reach a conclusion and not any ambiguity to what it means. This is opposed to natural languages like English. I mean, if English is a good example because it stems from Romantic languages. It shows like, the study of etymology, the study of root of words, of how words have been evolved over time. And so with natural languages, if certain phrases lose meaning and um, what is generally has a consensus on what words mean changes in dictionaries change, they're adapted over time, different dialects, different words, new inventions constantly adapt within our vocabulary base, and and it's constantly evolving based on the way people talk, based on the way slang is adapted. And this is beautiful for expression in art and conveying new meanings, but it makes it extremely difficult for a computer to analyze what text is programmatically because of the ambiguity and because it's ever so evolving. So that's where natural language processing, NLP in this case, kind of comes to about, which is a field of computer science or data science that takes all the textual data that we have in the world and tries to make meaning of it. And there's a certain structure that kind of goes to that. So so Story Analyzer is Dr. Michu's a professor at JMU who's been advising me on my Twitter research. To basically he uses NLP to look at different documents with political importance, so you can more easily see who did what to who, what are the nouns, the verbs, what are it's very difficult. For example, if someone says, you know, he did this, you don't know who he's talking about, especially in long places of text, and when you're trying to see important actors and how people relate to what and make inferences and business intelligence decisions based on text, this is very important. So in here he has a presentation, if you click here, that goes all the way up to, I'm going to just click it again. It basically is a great breakdown and a great introduction to NLP and helped me in my understanding. So what his Story Analyzer uses is Stanford's Core NLP API, which is basically a way that you can put sentences and then it will parse it and give you this information that his dashboard shows. And so basically the whole point is that it provides a narrative rather than just a keyword search which indicates the presence of. This allows you to see who does what to where, times and places, organizations and people, and it uses AI and machine learning models to basically understand what's going on. So it's tapping into this ever expanding knowledge of how we interpret human languages. And so it's a mix of AI and computational linguistics. And so Stanford's Core NLP is based on Java, and how it works is that it originally takes a sentence, it splits it into individual words or tokens or symbols or punctuation marks, just like if you were parsing a document, each of the things would be a token. That's like it's just a grouping of characters per se, and then from that, from each token, you begin to identify the parts of speech, whether it's a noun, a verb, adjective, adverb. This is very simple. All words in our dictionaries, have these labels. This is rudimentary kind of knowledge, but again, their AI is, kind of adding to that based on what they define as nouns. And then from deciding what a noun is, or a verb, or adjective, especially with nouns, you can start to see which of these are people. And these have tags like organizations and places. And then it also has things like time and um, you know other things as well. And then constituency parsing, then you start to, when you have these actors or important things or places to go to, you want to see how the sentence is structured naturally, whether it's a noun, or a subject, or an article, or a verb. You want to see what's its relation in rudimentary languages. And then dependency parsing, you want to see what each person does to what. So if I am someone throwing a ball, am I throwing a ball? Is the ball throwing me? This is very important to understand the meaning of something. Then what co-referencing is, especially in long documents where pronouns are not present, you have to see that the he and she matches up correspondingly, and that they might be referring to the same person in the text. And if they are, different actions are happening to the same person, then it shows that a broader narrative of what's happening to a person, especially for making AI decisions based on text. This is the most important. And just it takes from just the presence of these keywords to meaning as to what is happening. And so then there's temporal tagging, and this deals with time expressions. So there's a quick breakdown of that. And when you run the core NLP server, you basically, in your local host, you basically get the same visualization where you can actually put, for an example, this is an example of NLP processing. And then it runs, and as each step, as from parts of speech, from the original tokens to named entities, the dependency parses each step, which you can comment out if you're doing this programmatically, is more computationally expensive, especially because this is just tagging based on existing dictionary lookups. This is kind of understanding why, what type of thing it is, whether it's a place, organization. This is actually showing you the relationship between each one, mapping each word to each word, so that becomes more computationally more computationally expensive. But then on top of that, the co-referencing makes you look at other things and make inferences about that. And each level that is more computationally expensive has a lower F1 score, where F1 is basically kind of accuracy and precision in machine learning models. And so you can see, as these steps increase, and as kind of the chances that this means this becomes more polynomially expensive, then the accuracy goes down, and that's kind of understood. So let's go back here, and so you can kind of see when you did something. Alright, so let's go back to that example. So you can see it's saying that NLP is an organization, natural language processing, and then this is showing you that this is dependent on this. This is each of these have their own tags that mean different things, and then enemy recognitions. And this is a good way to see when you're coding what to do. So if you say CNN is a good news organization, not You can see CNN is a noun. It turns a noun into an organization. This is also a noun. This is also a noun. This is a verb, and then it just takes the dependency. It takes the noun, and then it gives these keywords, which we'll go over later. And then it has this enhanced dependencies, which again takes way more time to compute. Let's go back to the PowerPoint. So sentence splitting is pretty easy. You can do this with like any programming, because originally, like without NLP, I was basically doing this. I was splitting the words, seeing which words are present. That's just string manipulation. It's intro to programming. You take away the periods, the question marks, the exclamation points, and then you break it up. Well, there is this kind of caveat that just because you are having a period doesn't mean you're at the end of the sentence, and then that requires greater language structure and understanding what nouns are and what not. And this is also what comes why a NLP is a more efficient way of doing this. And then so like so it, yeah, so core NLP, it says it splits these into individual constituents instead of punctuations. And after it gets those tokens, then it begins to actually see what what is the part of speech, what is the noun. And for me, I'm especially looking for nouns and then verbs and their relationships, you feel, because that's actions, and who's doing action kind of defines a player, especially for me when I'm looking at protest tweets. So if you go, this is actually a key, and it's called the Penn Tree Bank Project by UPenn, and it basically is a key to do this like this. And so when you're actually going to the NLP processor, you can just say if this RR if it's the key for the part of speech, and there's a value for the part of speech key, the POS key. And so one thing that I'm doing is I just say if NN is there to get all the nouns, and then I can sort later, or I can just use the named entity recognition to actually get the more specific parts of the nouns, because that is the next step. And then there's again currency, time, date, nationality, religion in the extended version. And so again, this is very important to see, like especially in a lot of my Twitter data, it's all created at a certain small interval. But when you're looking at things like the Mueller report or other pieces of history, understanding a time and date, and then having a tool like Story Analyzer, which can map it over a long time, gets a better idea of timeline, and it gives a better idea of kind of basically making a snapshot of history in a programmatic way. So constituency parsing is what we're talking about, the hierarchy of phrases in natural languages. And this is kind of an example. This is basically how they taught us English in grammar school. We got the sentence, it's a noun and the verb phrase, and then the verb and a noun. And you can add adjectives on top of that. And this also goes back to the Penn Tree Bank. So let's go back to the slide. Now there's dependency parsing. What's dependent on this? So this is the subject, this is the object. The subject is who's the main actor, and the object is the thing that the main actor is doing the verb on. So there is also this concept of dependent and governor. And so the dependent points to the governor. So let's see in this picture, what is it pointing to? It's saying the dependent points to the governor. So the big is dependent on the governor, which is the dog. Does that make sense? So the and big wouldn't mean anything without the dog. If it were in a tree, in the hierarchy of the tree, if the dog was gone, the whole meaning, this could not exist independently. Similarly, chase is dependent on the governor, because without something being chased, there wouldn't be anything. So you see there's kind of a hierarchy. Things were being done, and you ask kind of the questions later. And then so John can exist without seeing, but this seeing could not exist without John or Bill. So it needs to be higher in the hierarchy, because this is what makes the meaning of the sentence. And then similarly, you see the cat is the main thing, and the is just kind of like prepositionally added to this. So if you look at it from a tree, chase would be higher, and then dog would be here, and then the and big would also be leaf nodes, where the parent would be the dog if you're looking at it from a tree-wise, which is kind of how compilers and language processing and tokenizing even work. And so then out of this, when you look at it from this, you can develop a dependency graph, and this is also shown as a noun structure, and there's a dependencies manual here. So again, you can see if the sentence is Bell, based in Los Angeles, makes and distributes electronic computer building products. So you're just kind of figuring out, because I didn't really look at the slide to be honest like that. I just like working these out. So Bell, based in Los Angeles, makes and distributes electronic computers and building products. So if we're looking at the same structure as last time, makes and distributes is the main thing going on. Without make and distribute, there wouldn't be anything going on. Like without C's, it wouldn't matter. John and Bill's relationship, but that's why it's there. That's the root of the tree per se. And then what's happening? Who makes what? So Bell makes it, and then based in Los Angeles is dependent on Bell. And then what does he make? Computer and building products, and this is all one. So let's see how this plays out in the dependency graph, and then we can look at this manual to actually see what these verbs mean. So you got makes and distributes, and this is conjunction and, so this is kind of together, and then this is kind of the noun subject related to it, and this is the dependent object. And it makes sense because Bell is the thing that's doing the thing, and the electronics are made by Bell, just as in John is the main thing that's seeing Bill. And so again, it works just like that. And then it's based in Los Angeles. Angeles is more, Los is prepositional, and then kind of makes sense how this stems out this, because this is dependent on this. It's describing Bell, which is the noun that's dependent on the main verb. And then computer, and then building products. And it's actually electronic computer and building products. And so it actually takes products, because these are all active describing this, and then it actually links all of these as these, and then adds conjunctions between both of them. So actually these are not that difficult to understand if you understand the stuff before. And so let's see, they have a whole paper. This is straight from that. And then it actually has the explanations of each thing if you want to get more into kind of the actual, if you're actually making an application that looks at this more in depth, or trying to make your own application, this actually gives a breakdown of languages and whatnot. And so I'm not going to go too into that. And awesome, it's right there too. Shout out to Dr. Mitri. And so again, this poses a question of who did what to whom. And so like there's and this is why language is so difficult, and it's so difficult to understand who does what to who, because you can see the actors, you can identify the actors, even though names for actors change and whatnot. That enough is pretty complicated. But seeing who does what to who is based on how these verbs sound, where they're placed, whether it's an active or passive voice as well. So they have agents, and they have passive things, and they have dependent objects, and all these other things as well. So kind of not gonna go way too into that, because kind of get the gist and you can go into that. But the idea of co-referencing is that it's mentioned, and so like this is very confusing, because he or she, this or that may be an inanimate object, and then whether they mention something in a different way, in a proper way, or whether it's male or female. And there's a lot of rules that deal with prepositional co-referencing or other mentioning, especially in this sample. Is he? Who is he? Is it Kasich? Is it Marco Rubio? It's how do you understand who's doing what to who and how this preposition has a relationship with. And so, and um, that's why these subject-object relationships is so important, because understanding who did what to who in what type of passive voice lets you jump to how the co-reference of identification um, is going on. Because if you don't know who's doing what to who, when they mention he, like in the sentence, how do you know that? And because of this, there are limitations. Each step is a process of how it parses. We talked about tokenizing, turning into a parts of speech, understanding the parts of speech, and then understanding the names, and then seeing how they're dependent, and then seeing how the nouns relate to the prepositions is all steps that are computationally more expensive. And like mentioned before, the F1 scores go all the way down. The parts of speech, it's pretty simple, 97, dependency 81, and then at the same thing, name entity recognition is 81, and co-reference is 60% inaccurate. And so this is something that I was taking into consideration, especially for tweets, where they might be referencing someone to another tweet, or they might be referencing something outside of context, and they might be using prepositions or sneak dissings or whatever, or and then using it in a slang way where the named entity might not be necessarily recognized. And a lot of times, and this is the main reason why originally when I was batching tweets for the story analyzer, they take large batches of text and then you run it and then you wait. And so I wanted to do this programmatically. So I made batches of text that I believed were that would run in a certain amount of time, given all the dependency parsings and the co-reference resolutions, and then I would paste it in there and wait for it to run. The reason why this is false is because, or well, this is inaccurate, is not only because tweets, that in colloquial slang, this is not being edited, so it's kind of our language in its most rawest form. But in addition to that, tweets, they are not co-referencing each other. When someone says he there and I concatenated it into one document, it's going to confuse the co-referencing because none of those things have anything to do with each other. So I think this is why when I was looking at my own individual use of natural language processing, I was hesitant to do co-referencing resolution because of its accuracy, and because would have to do it on individual tweets. And with this character limits and with like 2 to 3 or 1 to 2 sentences, it's kind of very ambiguous. If you use a preposition, you're either referring to the thing in the last sentence, and it's better to do it on individual tweets. But again, that's another consideration to go through as well. So these are another test and whatnot, and these are a common data visualizations found in NLP processing. So if you're making your own application, and Story Analyzer is a good example of that, you can show like what we did using this tree structure um, where you move down kind of these like these mind maps and these word clouds and these visualizations that the CoreNLP server did as well. So this is another way of visualizing based on Story Analyzer's architecture. So they take the text documents in the story, they information expression. This is the Story Analyzer that we said, and then we basically got all these lists of objects, and then you take all these lists and these data that are made from the JSON kind of output or the text or the XML output you get from this, and then you turn that into a visualization model. In this case, it's word clouds or whatnot. In my case, I'm taking tweets from the Twitter API. I am going into the extraction model. I'm keeping track of the parts of speech, named entity recognition, and then I'm turning that into list, a counter list, and then I'm making aggregate pie charts. I'm making word clouds, and then I'm making bar graphs on this. So let's just kind of see Story Analyzer, see what is kind of an implementation of that. And so let's go to, so as you see now you can, and this is what makes it so it forwarded, because when you go to sentence, it shows this of how it would be highlighted in Story Analyzer. So right now, you can see kind of the verbs being highlighted as well, and stuff in relation as you highlight the document. And then if you go down here, you can see those peoples and groups. So you can see Director Kobe's is mentioned a lot. He has an impact of 93, which necessarily doesn't mean the count. And so this is kind of more meaningful than just counts. And then you can see who he interacted with as you go on his name. It shows other names and other parties he's acted with in red. And then you can see their interactions in a map like this. And then you can also see dates and times, and it gives you a story of when stuff happened. So you're saying, like, at this time, and then you can see where it was mentioned. So again, you can move through a document in a time linearly when it's jumping through the document, and that's what makes it useful as well. And so there's also location, so you can see where things happened out. And again, it establishes like this international. This is Russia, this is the United States. What's going on here? And then again, these were clouds. And to me, the reason why this was useful is because just having percentages and manually putting stuff that I was getting kind of no information, and natural language processing really makes you have meaning of text, and you can get text everywhere. And so I think that's it's very useful information to know, and I'm glad I started learning natural language processing. And so yeah, that's pretty much kind of the intro to NLP. That was very long, and this is more information about the Story Analyzer dashboard, which I think I've done a video on.